on his journey, Travis completed his undergraduate studies at the University of Manitoba in Canada, and then completed his Masters and Ph.D. in psychology at Brock University, which is also in Ontario, St. Catharines, under the supervision of Dr. Cheryl McCormick, where he held an NSERC graduate scholarship. He then went on to complete a postdoctoral fellowship in the laboratory of me at University of British Columbia, and he acquired funding from the Institute of Mental Health Marshall's Fellows Program and also the cluster. A cluster grant, Catalyst grant from the Women's Health Research Institute. Travis has won many travel awards, presentation awards, and poster awards at international conferences. You'll see in a minute, well earned, because he is a fantastic, effective communicator, and he's devoted to mentorship and providing a safe environment for all trainees to enjoy science. He is also devoted to promoting equity, diversity, and inclusion through connections with the Women's Health Research Cluster, as well as Black in the Neuro. So please check all of those out. They're really amazing. And without further ado, I give you the floor, Dr. Hodges.
Thank you very much. And I'm happy to be presenting to you all, and hopefully you can all hear me. I'm good to go. Okay, perfect. So you can see my slides. Okay, great. Yes, I'm happy to be here to talk to you a bit about some of my research. A lot of the research I'll be talking about is from my postdoctoral work with Liisa, and also a bit of the work that I'm starting in my new lab now in Massachusetts. I'll talk to you a little bit about what we're doing today. So first, I also have my own acknowledgements. I'm thankful and I'm humbled to be teaching and talking to you all from the traditional and ancestral land of the Nonotuck people. I'm also thankful that a lot of the work I'm going to be talking about today was done on the lands of the Coast Salish peoples and the traditional territories of the Musqueam, Squamish, and Tsleil-Waututh nations. I usually, in my talks, talk about the Women's Health Research Cluster and give people, if people want to learn more about Indigenous women's health, there are some talks that the cluster do give and have given, especially in this same seminar series. There was a talk by Dr. Karina Walters that can be found on the YouTube right now, talking about trauma, historical trauma. So very much invite you to go see those talks, and I'm always happy to hear any other information people can give me about Indigenous peoples, and I'm happy to provide all the links that I have that I can give to others. So yes, thank you very much. And today I'll be talking to you a lot about major depressive disorder, because that is what a lot of my work is involved in. Major depressive disorder, it affects more than 300 million people worldwide, and it has poor treatment outcomes. For example, over 50% of individuals in remission will have symptoms return, and this could be due to the heterogeneity of the disease. And by heterogeneity of the disease, I'm meaning things such as the amount of symptoms of depression. There are many, and many subsymptoms. Here is a small list. But to be diagnosed with depression, there are over 256 unique symptom combinations that someone can have. From things such as too much sleep to too little sleep can both be symptoms of depression. And in addition to these many, many symptoms, there are also sex differences in depression, with women twice as likely to develop depression than men. There's also age differences in depression, with 38% of major depressive disorder onset before the age of 18. And this is also more so in women than in men. So there are major sex and age differences in depression. However, a lot of studies, most studies, have been done in adult males. And so a lot of my work aims at examining multiple different age groups and examining sex-specific effects when it comes to depression. And this is also in rodent models of depression, which is what I am the most used to. Rodent models of depression usually involve some sort of either injection with a glucocorticoid, a stress hormone, or a stressor itself, such as early life stress, social defeat, social instability stress. There's also chronic and predictable stress, which combines multiple stressors that these rats will be exposed to multiple times per day. The two stressors that I have the most and I've used the most in my PhD and my postdoc are social instability stress and chronic unpredictable stress. So I'll be talking to you about both of these a little bit today. Now, when measuring depressive symptoms in rodents, there are several symptoms that we can look at. Most studies examine what is called passive coping, examining things such as learned helplessness, and looking at the rat's likelihood to stop trying to escape a situation and to just stop moving. Or looking at anhedonia, looking at sucrose preference, how rewarding sugary things are, is another test that people use in rodents. I was very interested, and I'm still interested, in the cognitive aspects of depression. And in particular, one cognitive symptom called cognitive bias is my main interest. Now, cognitive bias, what is it? It is the interpretation or perception of ambiguous stimuli, situations, or events as either negative or positive. And this is affected by our mood, either being in a negative mood or a positive mood. One example of this that I love to give is in a picture of me wearing the same exact shirt that I'm wearing right now for this presentation, in which if someone were to ask you an ambiguous question or give you an ambiguous phrase, such as, that is an interesting shirt you have on, would you take that more negatively or more positively? I, of course, as a lot of people in here know that I have a very strong positive cognitive bias, and I would take that phrase as very positive. But a lot of people would not, and definitely those depressed individuals interpret phrases that are ambiguous like that as more negatively than non-depressed individuals. And that is what is called a negative cognitive bias. And I study in particular negative cognitive biases and trying to find new ways to reduce those negative cognitive biases. So what does negative cognitive bias do? It is a key symptom of depression. It increases with the severity of major depressive disorder and with age. It is able to predict the onset of future depressive episodes, and in particular in adolescent girls, not adolescent boys, showing that there can be some age and sex differences in the impact of these cognitive biases. Also, cognitive symptoms of depression have been found to be more severe in women than in men, in particular, looking at rumination and paying close attention to negative thoughts and negative thinking. So reasons why I'm interested in negative cognitive bias for sure are that they are fairly treatment resistant. They remain increased in formerly depressed individuals. And this is even after treatments such as cognitive bias modification therapy, antidepressants, which do not reduce negative cognitive bias in the long term. And so there's been for a bit now a call to action to try and reduce this symptom of depression and find new ways to treat negative cognitive bias. So what my work does is I examine cognitive bias in rodents and try to find mechanisms underlying this cognitive bias to find new treatments to reduce it. One of the cognitive bias tasks that I'm going to be talking about the most during this presentation is a fear-based cognitive bias task, which involves exposing the rats to a context paired with a negative stimulus, in this case, a foot shock. The context itself would have a pattern of walls, a certain kind of lighting in the context, so they would pair it with that. And in anticipation of that foot shock and going into that context, the rats would freeze. Versus another context, the rats were not exposed to a foot shock. In this context, it had different patterns on the walls, different lighting again. And in this context, the rats would just move around, sniffing all the walls, lots of exploratory behavior in the non-shock paired context. So I would train them on these two contexts for every day for 16 days until they learned to distinguish between the two. And then I would give them an ambiguous context. So similar to that ambiguous line about that's an interesting shirt you have on, I would give them an ambiguous context that looks a little bit like context A and a little bit like context B, and see, do they automatically respond with high freezing? So, and this would be having a more negative cognitive bias, or do they automatically respond with low freezing, which would be more indicative of a neutral or more positive cognitive bias? And some of the first studies that I did on negative cognitive bias, I examined in male and female rats, and in adolescence, young adulthood, and in middle-aged animals. So what did I find? In terms of behavior, looking at how the rats learn the task across the days, here we can see with the dark blue circles and the dark red circles are the rats going into the shock period context. And on the y-axis, this is the amount of freezing that they're doing. The light blue and the light red are the rats going into the non-shock period context. And we can see that by about day 10, these are adolescents right here, the rats learn to distinguish between the two contexts, freeze more in the negative versus the more positive context. A similar thing holds true for the young adults and middle-aged adults. They might learn a little bit slower than the adolescents, but by the time day 16 comes, all rats freeze the same amount in the shock period context, and all rats do not freeze the same amount in the no shock period context. So what does their cognitive biases look like? Here is some data of mine that was collected thanks to two amazing undergraduate students, Grace Lee and Sophia No. I thank them very much for this, and we have a paper published together with Liisa in Neurobiology of Stress. And for this figure that I'm about to show you, the higher the bars, the more of a negative cognitive bias the animals have. This is a negative cognitive bias score. The closer they are to 0, however, and these adolescents that I'm showing here are close to the 0 line, is a more neutral cognitive bias. And I'm also showing you all the individual data points. Any rats below the 0 line had a more positive cognitive bias in the ambiguous context. Any rats high above the 0 line had a more negative cognitive bias. So here we can see in the adolescents, on average, they had about a neutral cognitive bias in the ambiguous context. And then when we looked at young adults and middle-aged adults, we find that they have a more negative cognitive bias compared to adolescents. So the cognitive bias is getting more negative with age. In particular, if we look at the males, who are the blue bars here, we see that the males are getting more and more negative with age. They have more negative cognitive bias in young adulthood and even more negative cognitive bias in middle age. Versus the females, what we're finding is, while they also get negative, have a more negative cognitive bias in young adulthood, it returns to being a more neutral cognitive bias in middle age. And thus a sex difference comes out in middle age, which is the reason that some of my talks are called grumpy old males or grumpy old men, is due to the fact that the male rats are getting more negative with age, and at middle age, definitely they're more negative than their female counterparts. So a question that I get asked a lot is negative or pessimistic thinking always bad? So when examining these rats, we have these middle-aged male rats that are displaying a more negative cognitive bias. And I forgot to say that these animals did not go through any kind of stressor beforehand. This was just examining their individual differences in cognitive bias with age. And so is negative cautious thinking always bad? My usual answer is not always. Sometimes it's good to be cautious. In those middle-aged male rats that are going through, well, all they've done is age, that have gone through the procedure of getting shocked in a certain context every single day for 16 days, is a good reason to be cautious of an ambiguous context where you do not know if a shock is going to come or not. It is strange that the adolescents, after going through getting shocked every single day for 16 days, do not freeze in the ambiguous context and continue running around like in the no shock period context. So sometimes it is good to be cautious. For my interests, it can result into poor outcome for people with depression in terms of predicting future depressive symptoms and future symptoms in people with depression in remission. So I am focused on trying to reduce negative cognitive bias in certain groups. to prevent this. And so to do that, I'm very interested in the underlying mechanisms of these biases. And I've looked at underlying mechanisms in all these animals that I've shown you so far. I've looked at neural activity and functional connectivity by examining immediate early gene, CFOS, as a marker of neural activation in the brain of all these animals. I've also examined inflammation in the brain of all these animals. Inflammation usually acting in response to injury and infection, but too high inflammation for too long can worsen symptoms, worsen conditions, and high pro-inflammation has been linked to depressive-like symptoms. So I'm very interested in that. I'm going to be neurogenesis. I'm also interested in the development of new neurons, and also gut microbiota. Very interested in this, as gut microbiota have been linked more and more frequently with symptoms of depression and anxiety-like symptoms as well. So today I'm going to be focused much more on these first three in terms of the animals that I just showed you. Starting with neural activity, I've examined neural activity using CFOS as a marker of neural activity in multiple different brain regions, in the frontal cortex, the nucleus accumbens, the dorsal hippocampus and the amygdala, as well as the ventral hippocampus. So 15 different brain regions and subregions total. And this was all thanks to 3 other amazing undergraduate students, Frankie, Cherise, and Riona, to help me collect these data. And I was very interested in these regions in particular, the frontal cortex, because of its link to inhibiting responses, nucleus accumbens with its link to rewards, dorsal hippocampus to memory, amygdala to fear and fear memory, and ventral hippocampus to its link to stress and also to fear memory. So very interested in all these regions and subregions. And so I'm going to show you some of my data on the neural activity after principal component analysis, which principal component analysis, what I used this to do was to simplify the data that I had, because again, I had 15 subregions here of so much CFOS data. What it will do is it'll look for patterns, and it found a pattern linking together nucleus accumbens, amygdala, and hippocampus in terms of how they correlate together. So brain regions involved in reward, fear, stress, and memory were all correlated together. All were high when the others were high in these animals, versus the frontal cortex and its connectivity within the brain region. So within these subregions of the frontal cortex. So regions involved in inhibiting responses were all correlated together. So what does this mean for my data? So we're looking at the first principal components. So we have nucleus accumbens, hippocampus, amygdala. What we find is that young adult females had greater activity in all these brain regions compared to young adult males when in the ambiguous context. So when performing the cognitive bias task in particular, young adult females had greater amounts of activity in these regions. There was also an age difference in that adolescents and young adults had higher amounts of neural activity in these regions compared to middle-aged adults who had less amounts of activity in those regions. So here we're finding some sex differences and some age and sex interactions in terms of when the activity in these regions is the highest, when they're making those choices of whether to freeze or not in this situation. In the frontal cortex, what we find, or what I have found, is that frontal cortex has greater involvement in adults compared to adolescents. So higher amounts of activity in the frontal cortex in young adults and middle-aged adults compared to adolescents. And this could be linked to those adolescent responses. So the adolescents in this case were much more, froze much less than the other animals. And so maybe it could be due to reduced inhibition in the adolescents. And this could be leading to them having a more neutral or more positive cognitive bias compared to their adult counterparts who had more frontal cortex activity controlling some of that amygdala and hippocampal functioning. things of the sort. So we'll talk a bit more about that later, but in summary of what I'm finding is from the nucleus accumbens, amygdala, and hippocampus, a lot of involvement in young adult females and their biases. And in the frontal cortex connectivity, a lot of involvement in adults and their cognitive biases. So some sex differences and some age differences in what brain regions might be involved. Just a little bit, I have examined some functional connectivity as well in all of these brain regions. And when I say functional connectivity, I'm looking at correlations between each of these brain regions and their subregions, and whether or not those correlations are positive, which are the red lines here, or negative, which are the blue lines here. And also how strong those correlations are, which you can see with the thicker lines versus the more thin lines. And in summary of these results, because this looks like a whole lot is going on, which a whole lot is in terms of connectivity, this is what's happening in the males, this is what's happening in the females. The biggest pattern that we find is between the frontal cortex and the ventral hippocampus, such that the males display much more negative connectivity between the frontal cortex and the ventral hippocampus, versus the females display a lot more positive connectivity, positive correlations between the frontal cortex and the ventral hippocampus. So we're finding sex differences with which brain regions are correlating together with these animals. So more negative connectivity in the males, more positive connectivity in the females. So moving on to inflammation. What is happening with inflammation in the brain? And a lot of my examining of inflammation was linked to what I found in neural activity. I examined the basolateral amygdala and the ventral hippocampus for inflammatory markers because they were found to have sex differences in activity in neural activity. So basolateral amygdala and ventral hippocampus both had higher activity in the females than in males. These regions also involved in fear and in stress responses. So very much interested in how these are related to their negative cognitive biases. So again, I examined multiple different cytokines and chemokine in this case. So I did perform another principal component analysis to hopefully simplify the data a little bit. In one principal component was examining examining ventral hippocampus versus basolateral amygdala cytokine and chemokine connectivity. And I'll let you know what this means in a second. So ventral hippocampus versus basolateral amygdala versus the second principal component was examining just who had high amounts of inflammation in the basolateral amygdala and the ventral hippocampus put together. So what does it look like for ventral hippocampus versus basolateral amygdala? So on this graph, what you'll see is anything above 0 are rats that had higher levels of cytokines in the ventral hippocampus. Everyone that's below 0 had higher cytokine levels in the basolateral amygdala. And what we see is adolescents in particular had high cytokine levels in the ventral hippocampus, specifically in the more so in the adolescent males compared to the adolescent females. And it seemed to go more towards the amygdala side with age. So middle-aged adults had more higher levels of cytokines in the basolateral amygdala than the adolescents did. So more ventral inflammation in the adolescents, more amygdala inflammation in the middle-aged adults, and young adults were in the middle in terms of their inflammation scores. And again, these are inflammatory responses to being in that ambiguous context and either freezing or not freezing. So who had just high amounts of inflammation in both regions? A lot of it is, we see a similar thing with those young adult females. So compared to young adult males, young adult females had greater amounts of inflammation in the amygdala and in the ventral hippocampus. So we find that that significant sex difference there. So similar to the young adult females having high amounts of neural activity, they also have high amounts of inflammation compared to young adult males. So in summary, cognitive bias in adolescent males appears to be linked to ventral hippocampal inflammation. Cognitive bias in middle-aged adults linked to basolateral amygdala inflammation. And then when it comes to just all inflammation, cognitive bias in young adult females seems to be linked to inflammation more so than young adult males. So again, we have age differences and we have sex differences in what could be linked to cognitive biases. So that's what's been found in the inflammation. For neurogenesis, when examining neurogenesis, I examined double cortin as a marker of immature neurons and found that in response to doing this task, adolescents and young adults had increased double cortin. So they're going through, getting shocked every single day and going through this task. By the end of the task, they have higher amounts of double cortin, adolescents and young adult males that go through this task compared to this control group that are the gray bars here that are called no shock controls. They went into the boxes but were never shocked ever. So those are those controls. And we find what others have found, that double cortin is higher in adolescent males, or higher in adolescents compared to the older age groups, but also higher in adolescent males compared to adolescent females. We also find too. So I have shown you so many different ways in which there are age and sex differences in response to cognitive bias testing. When examining the sex differences in particular, we're finding activation of the amygdala, hippocampus, and nucleus accumbens in young adult females, as well as high inflammation in the basolateral amygdala and ventral hippocampus in young adult females. All of this compared to young adult males. Also, other sex differences we're finding are in adolescent males having higher amounts of ventral hippocampal inflammation and higher amounts of double cortin compared to females in this task. So from here, we're seeing, especially when looking at inflammation versus double cortin, we're seeing that these young adult females, they're getting this higher amounts of inflammation. And for double cortin, something seems to be coming out for the males, at least for adolescent males. And in another study, a group of studies, I examined similar mechanisms to see if they remain true after exposing these rats to chronic unpredictable stress. So this time, in this group of animals I'm about to show you, I did do stressor first. So 14 days of chronic unpredictable stress. So multiple different stressors. Then I did the cognitive bias task. And I looked at this compared to a group that had no chronic unpredictable stress and only did the cognitive bias task. And I did this in young adult males and females. Collected brains, blood samples, feces and colons for gut microbiota. And this is some of the results that we got from these animals. And we'll see hopefully some similar patterns. So when it comes to their behavior, the non-stressed animals are the NS here. Compared to the stressed animals, we find the stressed animals have higher amounts of freezing, more negative cognitive bias in the ambiguous context. So this is in the ambiguous context. So after going through a stress procedure, they're displaying higher amounts of freezing behavior. When examining neural activity, there's one region, the lateral amygdala, that both males and females, the more neural activity in the lateral amygdala, the more negative cognitive bias in both males and females was found. So this brain region and lateral amygdala very much involved in fear behavior. We are finding this increased activity is linked to increased negative cognitive bias correlationally. We're also finding a sex difference in that the amygdala, in the hippocampus, in the dorsal hippocampus, greater amount of activity in the dorsal hippocampus is linked to more negative cognitive bias in males, versus greater amount of neural activity in the ventral hippocampus is linked to more negative cognitive bias in females. So different regions of the hippocampus, one more so involved in spatial processing and memory, seems to be linked to the male negative cognitive bias. One more involved in stress and anxiety seems to be more linked to the female cognitive bias, negative cognitive bias, I should say. So we're finding sex differences in what regions are involved in these biases. We're also, when examining inflammation and looking at basal amygdala, what we're finding is that after stress, so again, the gray bars here are rats that were not stressed at all. Males are reducing in their inflammatory levels, though females are increasing in their inflammatory levels after stress. So they go through the stress procedure, and this is right after the ambiguous context. We're measuring cytokines in their brain, in the basal amygdala. Females that are stressed have higher amounts of IL-1 beta and higher amounts of TNF alpha in the basal amygdala. They also have higher amounts of IL-4 and higher amounts of IL-10 in the basal amygdala. But one link that we're finding when looking at correlations is the greater amount of TNF alpha level, the higher amount of negative cognitive bias in females, not found in males. We're finding. Versus in the ventral hippocampus, what we're finding is greater amounts of ventrohippocampal inflammation, lower amount of negative cognitive bias, so more positive cognitive bias in the males. So here we're seeing that maybe in females, inflammation seems to be tied to, or an increased inflammation seems to be tied to more so female negative cognitive bias, maybe more so than male negative cognitive bias. Now, neurogenesis, when examining neurogenesis, also looking at double cortin in dorsal and ventral hippocampus, we're finding that as double cortin increases, there is greater negative cognitive bias in males, and that is in both the dorsal and ventral hippocampus. So here we're seeing maybe more of a link to negative cognitive bias in males of neurogenesis. So when examining, if we were to try and examine positive cognitive bias based on the results that I've shown you, what we would hope to do is reduce dorsal dentate gyrus and reduce lateral amygdala activation in males versus reduce ventral hippocampus, CA1, and lateral amygdala activation in females. So this is what we'd have to do to hopefully increase a more positive cognitive bias in these animals. In males, we'd have to increase ventral hippocampal inflammation, whereas in females, we'd have to reduce basolateral amygdala inflammation to try and get to this effect. And in males, we'd have to reduce dorsal and ventral hippocampal neurogenesis to try and reach a more positive cognitive bias. And these aspects go right into what is next for my lab, what's next for my lab at the moment. So based on these data of this need for or link of inflammation in females to their biases and link of neurogenesis to the male cognitive biases, future studies in my lab, and hopefully starting this summer, actually, we are looking to reduce inflammation and reduce neurogenesis in these specific regions to see if that would lead to a sex-specific increase in positive cognitive bias in these animals. So DREADS for reducing double cortin, as well as some drugs, anakinra, for reducing inflammation to see if these would have sex-specific effects in reducing negative cognitive bias and increasing a more positive cognitive bias in these animals. So those are a couple of things that are up next in my lab. Also, what is next to for my lab is linked to the other stressor that I have lots of experience with, which is social instability stress. Social instability stress, a task that I use is developed by Dr. Cheryl McCormick, my PhD supervisor, in which we have rats that are housed, pair housed. We isolate them, and then we switch their cage partners. And we do this every single day for 16 days in adolescence. So it's an adolescent social stressor. And this switching of cage mates, the social instability, has been shown to increase risk for things such as increased mental health risk, which has been found in humans as well as in my PhD work in rodents. And I'll show you a bit of some work that kind of links the two. So what they've been finding in humans is for at least for kids that are changing schools multiple times, if they're closer to adolescence when switching schools multiple times, they have greater risk for attempted suicide, for violent offending, for psychiatric disorders, and for substance abuse. And this is a lot more after the age of 10, less so under the age of 10. And this is data collected by Webb and colleagues in 2016. So less so under the age of 10, more so over the age of 10. And that risk, the purple line that you see is if they move schools more than once. And the yellow line is if they move school once in their lives. So we're examining something similar to this, but in rodents. And what we find in these rodents is anxiety increases. So they have increased anxiety-like behavior. Sexual performance decreases. Aggression increases. So that increased aggression might be linked to or might be related to something with that violent offending that's found in humans. And their alcohol preference also increases, which could also be linked to that or is similar to that finding of increased substance abuse in humans. So in rats that go through this switching cage partners in adolescence multiple times, they have increased anxiety, reduced sexual performance, increased aggression, increased alcohol preference. And these similar things are not found if you do the same stressor in adulthood. So very specific to the adolescent period. So future studies of mine are going to be examining this social instability stress in adolescence. A lot of the information that I provided you so far about stress's effects on cognitive bias were in adults, young adults, looking at males and females. I want to look at stress in adolescence, and so I'm planning to use a stressor, this stressor in particular, social instability stress, to look at fear-based cognitive bias in adolescence, and also look at all those mechanisms that I've looked at before. I am also examining right now, as we speak this morning, examining another cognitive bias task, a reward-based cognitive bias task, and seeing the effects of stress on that reward-based cognitive bias. See if the similar brain regions and similar mechanisms are involved in reward-based cognitive bias as are involved in fear-based cognitive bias. And this is work that I'm doing with my new group of students, and here's a picture of all of us that we took together very recently. We're all working together to design and optimize this new reward-based cognitive bias task based on previous work to see if we can find similarities between the mechanisms between the two tasks. So I'd like to thank the Hodges Laboratory that are featured here in this picture. I'd also like to thank and acknowledge my two previous lab families, the McCormick Lab, as well as the Galea Lab. The Galea Lab especially for helping collect a lot of the work and helping me figure out a lot of the work that I've shown here. And I'd love to acknowledge all of my funding resources. And if you have any questions, I welcome them wholeheartedly. If you have any questions I don't get to today, feel free to email me because I'd appreciate that as well. And thank you very much.
Well, thank you so much, Dr. Hodges. If you can, please give a little emoji so that we can acknowledge this, because it's always hard to do in our virtual environments. But it's great. We're very grateful for people still continuing to do this because then we can reach more people. So there's actually a couple of questions already for you in the chat. So yes. I don't know if Chris or Ariel, you want to ask yourself or you want me to ask for you. I'm happy to do that. I can ask Chris's first. So it sounds like negative confidence bias for female rats is more like a higher threat awareness, perhaps during the reproductive years.
Mhm.
What do you think about that?
Yes,
And how could
very interesting.
yeah,
The thing about, so yes, and I think that this is targeting those young adult females
yeah,
and their increased negative cognitive bias, and also increased inflammation and increased everything else. And then
But did you
the
look
middle
at
age,
estrous cycle?
well, I was going to say, and I looked at estrous cycle, and I was also going to say the middle age group that I took, I call the middle age group, and they do get more positive with their biases, but they are not quite, they're still in their reproductive years during that, um, when I sampled those animals too. They weren't, I am interested in looking at an older rat group to see if a similar thing is found, or maybe they go back to having a more negative cognitive bias, or maybe they remain more positive cognitive bias with age then too. I did examine menstrual cycle, did not find much linked to menstrual cycle in these animals and linked to their cognitive biases. Um, the most I found was parts of the phases of the cycle that have higher amounts of progesterone in them. It's menestrus. Seemed to be linked to, not significantly, but seeming to have some kind of trend toward more of a negative cognitive bias. But I need to look more closely at the hormones in particular to see if there might be a link there to those biases.
But it's also an interesting because of course in preclinical work it's hard for us to exactly determine what some of our results mean, but the threat awareness is kind of interesting. Like I guess it kind of goes towards the question that you had before about like, is it a bad thing? Like it could be, oh, you're more cautious because,
Mm-hmm.
but is it really cautious? Or are you predicting that you might get more, so it might be more like a threat awareness. It's also
Yeah,
really,
especially in young adulthood.
yeah, especially in young adulthood. Yeah, exactly.
He's threat
Kind of an
awareness.
interesting question. And then how
Yeah.
could you choose that apart would be kind of an interesting.
Mm-hmm. Very
Um,
interesting.
and Ariel, so thank you for the question, Chris. Ariel asks, unless Ariel wants to. Ariel, oh, Paul Shepard also has a question. So let's do Ariel's first and then Paul Shepard, which is awesome that we get to see Paul as well.
Yeah.
What does negative correlation in brain activity and the positive correlation in females' brain activity mean in terms of behavior? Which
Mm-hmm.
did you
Yes.
show
So
or only in relation?
yeah.
Yeah.
So yes. Yeah. So this is referring to the functional connectivity, and those, so that frontal cortex and the ventral hippocampus having more negative correlations together in those male groups versus the frontal cortex and the ventral hippocampus having more positive correlations together in the female groups. What it means in terms of behavior, and I'm trying to think back to what I examined in the data at the time. I think it's still not sure. I think it's one of those things that I'm hoping to
I think you looked at
soon.
correlations, but I don't remember which way they went
Yes, I looked at correlations.
between behavior and the, I
I
guess there's so many.
Yes, and I know that one thing I'm interested in, if not this summer, but another summer, or later on. I am interested in that. Um, So with that positive correlation in the females, if we reduce activity in one of those brain regions that had the higher activity
Right.
in the females, would that then reduce negative cognitive bias just in general? Because females just had higher activity in most brain regions in response to the ambiguous context. So what would happen if we reduced one of those, and how would that affect the activity of the other brain regions that are connected? I'm interested in doing that. I think we have that also in a part of a grant, maybe, that I'm interested in looking at in the future for sure, Ariel. because still unknown.
Yeah, stay tuned.
Stay tuned.
Gail has a question, and so does Paul.
Yeah.
They're both very interesting, I'm sure. Paul, I think you might have been first, even though Gail's is up. So if you would like to, there you go.
Hi.
Paul.
Hello. Travis, that was awesome. And I have lots of questions, but I'll keep it to one. But I am going to follow up with you about your DREADS experiment because I'm very interested.
Yes, sounds great.
That. So and we've had this conversation before, and a lot of your data, so at least for the older age group, back this up. There is an inherent level of pattern separation that occurs in cognitive judgment bias. It is just sort of, it's part of the process. It has to be. Like you're taking an ambiguous situation and it's like, can you parse it? I guess my question is sort of high level. Can we disentangle pattern separation from cognitive judgment bias, and how? And I think your young adulthood group is this really interesting in between point, because like your data sort of support like, oh, the adolescents might be this greater strength of pattern separation. They can tell the different contexts apart better, and the older age group, they can't, because their neurogenesis and things that support pattern separation have sort of collapsed. But your middle group is really interesting. I think that's where there's a lot of interest. But can we sort of tease these cognitive processes apart, or are they inherently linked?
Yeah, well, great question. And then I will say that because the adolescents, like by the time they're all going into the ambiguous context, by that time, they're all freezing the same amount in that shock period context. They're all not freezing the same amount in that no shock period context, which is something that I was concerned about before. Maybe the adolescents are just freezing less overall, but they all are following the same, reaching the same point, which is great. A good start off point. So when the adolescents do not freeze in that ambiguous context, it does seem very much linked to, they're tying this context to that no shock paired versus those middle-aged males, which seem to be tying it directly to that shock paired context. So I think that the pattern separation at least seems to be similar between the age groups, that pattern separation part. Can we tease it apart? Even the task that I'm working on right now, which is a reward-based cognitive bias task, no foot shocks, it's still I'd still say it's still a pattern separation task. Being able to tell apart what should be considered more positive and what should be considered more negative is that pattern separation, and then giving them that ambiguous context to tell between the two. I do think that they're linked, very much so linked. I'd be interested to find a way to examine cognitive bias without pattern separation, but I feel like you always need that pattern separation, so then you can reach that ambiguous point of, now look at them together. Well, yeah, what does it mean?
If you probe pattern separation after this, you might have an effect. If you probe other affect measures, you might have an effect as well.
And there might be linked. And there might be differences by sex and age. That's, I think, what for sure. Data showing. Thank you, Paul.
Thank you. Yeah, it's awesome.
Gail has a great question here. Sorry if I missed this, but do you think there'll be different brain regions, mechanisms associated with chronic stress versus social stress? Because chronic stress, of course, is more physical, whereas which I'm not positive, it's all physical, but some of it is, whereas the social stress are more social. So you expect different outcomes and different brain regions to be activated, or other biomarkers?
Yeah, great question. The chronic stress procedure does include some social stressors in there. So there is a link, because the chronic unpredictable, there's so many different stressors in the chronic unpredictable stress. Some of them are social, some of them are not. Definitely, when I'm examining the brains of those animals after going through the social instability stress, due to my previous work, I'm going to be very interested in the lateral septum, because I found some major differences in what happens to the lateral septum after that kind of task, and how that links to behaviors later on. Also, the medial amygdala, I found many differences, especially in the postero-dorsal parts of the medial amygdala had very much a role in some of the behavioral changes that I was seeing after doing that social instability stress task. So I will examine those regions specifically to see if there's anything linking those to then biases later on, or changes in those regions to biases later on. It could be directly, it could be indirectly through influences on connectivity with other regions, things of the sort. But I am interested in a couple different regions linked to that social stressor. Yeah, great question.
Yeah, and I think you would predict that there'd be different, and maybe other certain areas might be more important for one versus the other.
Yes, I'm hoping to find some differences and then also some similarities in some regions, hopefully in the basal amygdala and ventral hippocampus.
Yeah, it's cool. Margarita asks, fascinating talk, thank you. Is there any data on menstrual cycle affecting cognitive bias and other markers like functional connectivity, inflammation, etc.?
Yes, great question. The cognitive bias literature there's not much. There's very few studies out there even linking stress to cognitive bias. And so I'm hoping, so my first study was also hope to link menstrual cycle to cognitive bias. I'm still hoping to examine hormones' effects on cognitive bias, because that hasn't yet really been done at all. So it would be interesting to see how these hormones are involved in these biases, because I'm sure that they're playing some sort of role, as they play a role in most everything. So very interested in that. In terms of functional connectivity and inflammation, I do know there's a link between neural activity, and I do know there's a link between inflammation. I can't remember the links at the moment, but I do know that they do play a role. And so I do want to, when I examined menstrual cycle information before, or estrus for these rats, when I examined estrus cycle before, I was looking specifically to their behavior, but I did not try linking to their inflammatory marker levels and their neural activity. So that is something I do want to attempt to do too. Yeah, great.
I think that'd be really great. And there is some human data. I don't think for negative bias or kind of bias per se, but like for functional connectivity in general, just not very much. So that's one thing I'm sure all of you are very well aware of, but there's very little data out there anyway, just looking at, menstrual cycle effects and a variety of outcomes. But it would be just like for resting state. I think there are probably Emily Jacobs or Claudia Barth has also done a little bit of, not a little bit, but some work in this area as well. Julia Sacher. But don't quote me on exactly what they found. But it's really great. Well, thank you so much, Dr. Travis. So good to see you. Oh, what?
Yeah.
Did you lose me? Did I lose you?
Another question.
Is there another question? Oh,
Ariel?
Oh, sorry. Yes. No, there's two more questions, but I figured that Ariel and Chris already had their questions, so that's probably why I dismissed them, but I didn't mean to dismiss them. You're absolutely right. In the future, how might this research be applied to help depressed young females or grumpy old males?
Yeah, I love it. Because yes, I'm hoping, well, now looking a bit closer to the mechanisms, I'm hoping to examine the effects of inflammation in the young adult females to see if there are different treatments out there. There are different supplements out there that already are linked to improving that kind of inflammation, or reducing that kind of inflammation. And I'm wondering if those would have a role then in reducing negative cognitive bias. And so I'm hoping to look at that connection for the females. For the grumpy old males, I'm hoping to look at a connection with the neurogenesis aspect, and see maybe there's a way to, in these animals, and seemingly reducing neurogenesis might help with their increase their positive cognitive bias, which could also be linked to reducing that threat response. So I am looking at there's different treatments like exercise and things that people could do to change, hopefully change neurogenesis. I am thinking about those and what that could mean for future applications tied to these results, but in humans, and some translational work.
Yeah.
So yes.
Absolutely. And Ariel says that it would be great to look at the relationship with cognitive bias and resilience. Yes, I absolutely agree.
Mm-hmm.
And Fatima also says she also thinks that it would menstrual cycle period and symptoms across the cycle would be really interesting topic, which I think is also true. And then you got 1 minute to answer this one. Have you considered not just an ambiguous context, but also completely new environment as a test of the acquired? I think it would be hard to do, right?
Yeah,
what would it tell you? But I mean, it certainly could tell you.
Yes, it's interesting.
Yeah.
I know that there's work that's been done before examining not thinking about cognitive bias, but work that's been done with fear conditioning and looking at training on a couple of different contexts and giving a third new context and seeing how much freezing they do in those boxes. But yes, it is different from what I'm trying to look at, which is them knowing, well, hopefully knowing which context is more likely to be tied to something negative, and which context is more likely to be tied to something positive, and giving them something that looks like both, and seeing do they think towards the negative or think towards the positive. That's what I am examining in particular. But yes, it'd be interesting to see a new.
Yeah, what that might mean. Amanda also says, hey, how could you separate that from neophobia? Which, I mean, it could be another, I wouldn't say that it would be a way of kind of bias testing, but it certainly could be, maybe, I don't know. Actually, it's an interesting question, Chris.
Very interesting question.
I shouldn't. Yeah.
Think about it. I'll be thinking about it.
Yeah, think about it. We are at time, so I just want to again say thank you. Please, a big round of applause to Dr. Hodges for giving his time in his very first year of being an assistant professor. It's kind of a crazy time, so we do appreciate the time and commitment that I have to both the cluster and for giving us this seminar today. We all learned a lot, and I tweeted all the stuff that was published already.
Thank you. Thank you.
And we'll see you all maybe in September.
More to come.
More to come.
Thank you very much. Thank you for having me.
Oh no, please. Thank you. I forgot to give your fun fact. Oh my God, I can't believe that. I know. After all that, that's hilarious. And I was saying to the lab, I'm like, oh, you know what? There's so many fun facts about dramas. I know them all already. I was going to say something about how I was going to talk about, of course, the movies that you love. He loves terrible movies. And then so much so that he's he has like viewing parties because he loves them so much. Terribly written, terribly acted, terribly directed, all of them.
Yep.
And also, I was going to say, and sometimes when you're nervous, you break into opera, which is another thing I remember.
That does happen and still happens in my classes.
Does it? Yeah. I don't know about nervousness, but whatever, when maybe you're not quite sure what to say.
Yes. Yes, that is right.
I love that. I love that about you. And we miss you very much. I'm sure you know that.
Yes. Miss you too. We will talk soon.